This video is on simple machines and the mechanical advantage. First, let's talk about what machines do. It's a device that makes work easier. It changes the amount, distance, and direction of force. Mechanical advantage, when you have an advantage of something, it means you're gonna do better. So it's the same thing with machines. Something about that machine makes the work easier. It has an advantage for the job. So mechanical advantage is used to measure these changes in force from using the machine. Large mechanical advantage means smaller force needed, work done more easily. So the bigger the number, the better the machine. Okay? Bigger the number, the better the machine. You have three equations that you're going to learn in this video. The first one is going to be IMA equals DE over dr. IMA stands for ideal mechanical advantage. Ideal means the perfect scenario. So this is what the machine is supposed to do. So IMA equals DE over dr. The D stands for distance. Okay, so when you look for IMA, you're going to be looking at the distance of how far the object is moving when the job is being done. The main thing you've got to understand from this video is what this E and this R stands for. So E is going to be the effort. So this is what the person is doing. And then the R stands for the resistance. So this is what the machine is doing. Okay? So the machine is doing. It's the same thing as the person is going to be the input. The machine is going to be the output. This right here is going to be the key to doing all the problems that we're going to do today. Okay? So when it comes to a ramp, shown in this picture, the person has to walk up the ramp like that, right? So that means if you were to redraw this, this value would be the DE because the person has to go that way, but the machine, which is the ramp here, the inclined plane, is actually bringing the object up. So that's going to be your dr. So when you have an inclined plane like this, to find the IMA, all you're going to do is the length, which is this, divided by the height. Same as this equation. Okay? So let's do a couple problems here. Calculate the ideal mechanical advantage of a ramp that is 6 meters long and 1.5 meters high. So if we were to draw this out, this would be 6 meters and this would be 1.5. So what is the person doing? Where are they walking? Are they going to walk straight up or are they going to walk along the inclined plane? They're going to walk across the they're going to walk across the inclined plane. Now remember, our formula is IMA equals DE over dr. Remember, whatever the person is doing is the DE, so that's 6 divided by 1.5, which gives you 4, and that is your answer. Okay, so let's look at the second example. IMA of a simple machine is 2.5, so the IMA is 2.5. If the output distance of the machine is 1 meter, so the output distance, you gotta look for keywords. It's not just looking at units this time. The output distance, so the output, remember, if you look back at this equation, the output is the same thing as the resistance. That means this value is our dr. What is the input distance? So input distance is the same thing as DE. So you're looking for DE. So now we need to bring in the whole triangle for this equation. So IMA equals DE over dr. So if we do the triangle for this, DE is already on top, so it goes on top of the triangle. IMA goes at the bottom, dr on the bottom. We're looking for DE, you shade it in, so then you get DE equals IMA times the dr. So for this one, it's going to be 2.5 times 1, which just equals 2.5. Okay? So now what I want you to do is try this one on your own. Pause the video for a second and come back to the video when you're done. Okay? So, what is the IMA? So you're looking for IMA. Sorry that it's dark. So remember, the equation is DE over dr. So you've got all these different values, you've got to figure out which one is which. So to use a 100-meter ramp to lift 4,500-pound car to a height of 2 meters. So what are you doing? You're going to walk along the ramp. So this is your DE. The height is always going to be your DR. So all you're doing is 100 divided by 2, which gives you 50. Now the most common mistake is to use this number here of 4,500 pounds, but the equation has nothing to do with the amount of weight of something. So you might have extra information, you just need to cross it out. When you're looking at IMA, you only look at the distance of things. Okay, now let's talk about real machines. Real machines in the real world always have to overcome friction. So remember, we just talked about ideal situations. Now we're going to talk about the real, what's actually happening. So the machines aren't going to work as good as they should based on the ideal mechanical advantage because of friction. This requires larger effort force. Conservation of energy, work done because of friction is lost to heat. So some of the work that you're putting into the machine is lost because of friction. What this means is your input work is always greater than your output. So here's the second equation for today. The AMA, which is the actual mechanical advantage, what is actually happening. Now what you need to see is that this is now going to be based on force. IMA is based on distance. AMA is based on force. Also, you still need to know what E and R stand for, and they are flipped. So make sure you look at the formula before you start assuming things. All right, so what this means is you're now going to put the output on top, which is what the machine is doing, divided by the input, which is what the person is doing. So for example, Alex pulls on the handle of a claw hammer with a force of 15 meters. Alex pulls with 15 newtons. So this is going to be your DE. That is what the person is doing. If the hammer has an actual mechanical advantage of 5.2, that means that 5.2 is your AMA. And it's asking how much force is exerted on the nail in the claw. So it's asking about the claw, which is the machine. So you're looking for the DR. Okay, so again, your formula is AMA equals FR over FE. Now, we're looking, I'm sorry, I put D, I meant to put F, I'm sorry. This is FE and this is FR because we're looking at forces this time, not distance. I'm sorry. Okay, so we're looking at forces, not distance. So if you were to draw the triangle for this, FR is already on top, so it goes on top, AMA and FE on the bottom. You're looking for FR, so this just means you're going to do the AMA times FE. So what that means, you're going to do 5.2 times 15, which is 78. Done. Okay? So if you exert 100 newtons, if you exert 100 newtons, that means the 100 newtons is, let's do it again, is your FE, because that's what you are doing, on a jack to lift a 10,000 Newton car. So this is what the machine has to do. It has to lift this car, so that is your FR. And it's asking for the AMA. So again, your equation, AMA equals FR over FE. So 10,000 divided by 100 equals 100. Okay? All right, one more formula. Efficiency. If I say you're efficient, that means you're working well. So the higher the efficiency, the better the machine. So efficiency, measure of how completely work input is converted into work output. So how much of that work you're putting in is coming out into the machine itself. Formula for this is efficiency equals work out over work in times 100. Your number will always be less than 100% because of friction. Okay, so let's look at an example. Alice and Jim calculate that the ramp must do 18,000 joules of work to push a piano up a ramp. Okay, So this is what they think is going to happen. So this is how much the piano is. So this is going to be your work out. This is what's supposed to happen. But because of friction, this is what they actually put into it. So this is the WN. This is the work they actually have to put into the problem. And it's finding the efficiency. So all you're going to do, again, work out over work in times 100. So you're going to do 1800 divided by 2400 times 100. And that gives you 75%. Okay, now this last problem is the hardest. So if you look, there is no work mentioned at all, and for the efficiency problem we need to do work. So what we need to do is bring in an old friend of work equals force times distance, because you have a force here, distance, force, distance. So what you're going to have to do, the first thing, is to find your work out and your work in. Okay, so you have to read the problem and figure out which numbers go with what. Remember, out is what the machine is doing, in is what you are doing. So a 900 Newton of force are used to push a lever down. So something's pushing the lever down. This is what you are doing. This is what's going into the machine. So these numbers are going to go for the in. So you're just going to do force times distance. So 900 times 1.3. And you should get that. Then that means the lever raises, okay, the lever raises, this is what the machine is doing. So you're now going to take these numbers and find the work out. So 2000 times, 0.4. So 2000 times 0.4, which gives you 800. So the next step is to now plug it into this equation. The work out over work in times 100. So the work out, 800 divided by times 100. And you should get 68%.